Welcome to our lesson on inverse functions. In our previous videos, we've talked about function operations where we add, subtract, multiply, and divide functions. In our last lesson, we talked about composing functions where we stuck one function inside another function. Here we're going to talk about inverse functions. And you already have the language for inverse functions. We're just going to use it with things that are newer in our curriculum. So look at example 1. We want to start out by taking our f of x and solving for y. Now, remember, when we talk about function notation, f of x is really just a fancy y. So we could write it y equals 2x plus 3. And we want to solve for x. So if we take our function and solve for x, we're trying to get x by itself. So we're going to subtract 3 from both sides, which gives us a y minus 3 equals 2x. Can't have the 2 over there, so we're going to divide each side by 2. And we're going to get x is equal to y minus 3 divided by 2. And so we've solved our function for x. Now, the question is asking, find the input when the output is negative 7. If you remember, input is your x value, output is your y value. So this time we know our y is negative 7. You could do this one of two ways. The first way you could do this is to take this negative 7 and just kind of plug it in up here. We already know that y equals 2x plus 3. So when we solve, we subtract 3 from both sides and then divide by 2 and we get negative 5. Or our new formula. Negative 7 and plug it in over here and use negative 7 minus 3 divided by 2 equals x. Well, negative 7 minus 3 is negative 10. Negative 10 divided by 2 is negative 5. And you might be thinking to yourself, you just said all of those same words, we just wrote it differently. Here, you used a two-step equation to solve for x to get negative 5. Here, we've already solved for x. We just had to plug in our number. We still subtracted 3 both times. We still divided by 2 both times. We just wrote it differently. That undo each other are called inverse functions. And we've already talked about different inverse operations. Perhaps one that you already remember is that addition and subtraction are inverses. Addition undoes subtraction, subtraction undoes addition. Maybe you're also thinking of multiplication and division. They undo each other. And perhaps one that's more recent on your memory would be the square and the square root, or the cube and the cube root. They cancel out or undo each other. So what is function and inverse? Look at these two tables. We're using the same exact formulas, equations, that we did in example 1. We've got 2x plus 3, and we have x minus 3 over 2. And we just want to see something that happens when we input, solve for these x values. What happens when we plug in negative 2? What happens when we plug in negative 1? I'm going to do these fairly quickly, so bear with me. Negative 2 times 2 is a negative 4, plus 3 is a negative 1. Negative 1 times 2 is a negative 2, plus 3 is a positive 1. 0 times 2 is 0, plus 3 is 3. 1 times 2 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. Well, what if I plug in to my inverse equation these numbers? What is negative 1 minus 3? Negative 4, divide by 2, that's negative 2. 1 minus 3 is negative 2, divide by 2, negative 1. 3 minus 3 is 0, 0 divided by 2 is 0. 5 minus 3 is 2, 2 divided by 2 is 1. 7 minus 3 is 4, 4 divided by 2 is 2. Do you see what happened? Your y values of one function became the x values of your inverse function. the x values of your original function became the y values for your inverse function. Our x's and y's switched places. We can also see this demonstrated on a graph. Back in geometry, you learned about reflections as types of transformations that happen to shapes, or lines in this case. And so we have two different lines here. We have our original line. Sorry, this is our y equals x minus 3 over 2 line. And this is our y equals 2x plus 3 line. And you'll notice that all of the points also match up. For instance, if we take this point right here and this point right here, you'll notice something. This point is 3, 0. This point here is 0, 3. The x's and y's change places. The type of reflection we learned in geometry that did this was a reflection over the line y equals x, because that meant your x's were y's and your y's were x's. And so you just had to flip the points to get your reflection. So bringing back that geometry for full circle, inverses are actually reflections of each other over the line y equals x. Now, what does this have to do with actually finding inverses and things like that? Looking at example 3, the question asks you to find the inverse for this function, f of x equals 3x minus 1. The first thing we want to do is switch our x and y. Remembering that f of x is really just a fancy y, we could write x equals 3y minus 1. The second thing we're going to do is we're going to actually solve for y. So we're going to add 1 to both sides. Then we're going to divide by 3 so that we get y to equal x plus 1 divided by 3. But this isn't just a normal y. This is actually my inverse y. Because my original y was 3x minus 1, we can't just leave this y. We have to make it into something called inverse notation. So what we have to do is we have to notate that what we've just found is actually the inverse of what we started with. So this second one here, we need to find the inverse of f of x equals x squared. And our first step is to switch the x and y. So we have x equals y squared. Well, to undo a square, we need to take the square root. So when we solve for y, we're going to take the square root of x. So y is going to equal the square root of x. Now this isn't our original y because we started with something that was being squared. So we need to notate that what we haven't found is the inverse of our y. Now, what does it mean to have this x is greater than or equal to 0? We've already studied the x squared function and the square root of x function, and what we know is that when we graph them, my original function, x squared, is a parabola. It looks like this. However, when I graph my square root of x function, it's not one-sided, it's only one-sided. It doesn't come down here as well and make like a parabola but facing the left direction or the right direction. This is why it only works when x is greater than 0. There is no inverse for the negative side of my graph. So when x is greater than 0, there's my inverse function. Do you see how these two things look like they are reflections of each other? That's only true for x squared functions or powers of even numbers. Take a look at number 5. Our first step would be to switch x and y. So what we're going to do is write x equals 2y cubed plus 1. Then we're going to start solving for y by subtracting 1 from both sides and then dividing by 2. So we have y cubed equals x minus 1 over 2. To undo a cube, we have to take the cube root. Our final answer here would be that our y is going to be the cube root of x minus 1 over 2. And we finally need to notate that this is not a normal y, it's actually our inverse y. Square root. Well, we're not going to do anything different. Again, we switch our x and our y, so we've got x equals 2 square root of y minus 3. We're going to solve, and so we need to divide each side by 2 first. So we're going to have x over 2 equals the square root of y minus 3. We can't add 3 because it's under the radical, so the first thing we need to do is square both sides. So you're going to have x squared over 4 equals y minus 3, squaring both the x and the 2. And so the last thing we'll do is add 3 to both sides. So we have x squared over 4 plus 3. This is not our original y, it's the inverse. So we notate it as such, and there's our answer. Now, what if you had two functions and someone asked you, are they inverses? You could probably pretty easily look at it and say, this one subtracts, this one adds. This one multiplies by 3, this one divides by 3. And you can quickly check, yes, indeed, they are inverses. But what we need to know, what connects the rest of our unit, is that inverses, when we compose them, we get x. Plain old x. Similarly, inverses, when it comes to addition, if you add the negative version, you should get 0. When you multiply the fraction, you get 1. Here, when we compose, we get x. So what we're going to do is stick one function inside the other function. It doesn't matter which way you go. I'm choosing to go f of g of x. You could, if it was simpler or easier and made more sense, you could go g of f of x. But we're going to stick our g function inside our f function. So our f function is 3x minus 1. And what we're doing is we're sticking our g of x function inside. So we're going to say x plus 1 over 3. Now something cool happens here. Your 3's cancel out. One's being multiplied, one's being divided. So you've got x plus 1 minus 1. Well, what happens when you have a plus 1 and a minus 1? They also cancel out, and you're left with just an x. So these two functions are indeed inverses.